So I'm Matthias, I'm working for Conceptual, small consulting, not so small anymore, consulting company in Germany doing software projects and also data projects. And in this role, I'm doing a lot of data architecture, data workshops, conceptual-wise. Sometimes I'm allowed to open the IDE, and I'm happily enjoying this. And last time, most of the time, it was actually DuckDB. So the usual question up front, who has heard of DuckDB? That's a lot of people, and I expected it. Who has actually worked with DuckDB? Now that's far less, but yeah, for you that already worked, you can sleep for 10 more minutes and then wake up. So what is DuckDB? Fast, in-process, analytical, open source, portable database system. Sounds great, isn't it? Before I explain all those, what is it and why is it cool, I thought about, hey, let's just do a demo. That's easier. So I'm on my command line here, and I'm starting DuckDB just over the command line. Where did I get DuckDB from? It's easier, just install it via brew or whatever package or whatever manager you might want to have. So it's just a CLI tool in this case, and I started with an UI that comes since a few weeks actually. Then I get those UI as well, but I could also use just this wrapper and execute SQL code here, like select ASB. So nothing special, just some SQL. So what can we do here? I might get a little bit bigger. So people that came up front are an advantage now, but. So what can we do? We can read JSON, for example, via SQL. This JSON is stored locally. We get the results here. We get also some profiling here. And we can do, of course, all the SQL stuff on this. You see some of the SQL sugar that DuckDB is adding as well. For instance, we don't specify by what we are grouping by which columns, but just say every column that doesn't have an aggregate function on it, just use those for aggregations. Okay, this isn't too impressive, I guess. But we can also query Parquet files here, and this Parquet file is stored on GitHub, so via HTTP. We can just access it and can do all the stuff on this, and all the all group bys and so on, all the SQL stuff we want to do. And we can also read JSON, unnest this. This is about space launches. We just have here, and it's basically in REST API, and we just query it via SQL. Getting a little bit more interesting. For me, this is actually one of the most used things because Parquet files are not that easily readable, and if they are just get some Parquet file and just want to take a look into it, just start up DuckDB, read the Parquet file via SQL, and look what is inside. Most of the time, the Parquet file is stored on blob storage. For instance, S3 might also be Azure Data Lake Gen 2 or GCS or whatever. And we can access this as well. So we just create a secret first, because this is also waste. You can happily copy those access keys. So forever, then you get access to exactly the data that we are showing here. So we scope this secret in this case, say, hey, whenever a request is coming to S3, test data Matthias, just use this secret. And we read this JSON, which is stored in S3 in this case. This is roughly 2.5 gigabytes, and right here, and select it. And so we can also have JSON gzip files, and just and DuckDB extracts those data first, gets all the data that is stored in these files, and we can happily query this data. We also have some SQL goodies. Some of them I told you already, so we can create a table as select, nothing special. So if we select a JSON file here, and then create a table T, we see this table T here stored in our memory database, coming to this later. Okay. We have some kind of cooler stuff like select star exclude instead of select column, everyone but the salary. Also nice syntax sugar. I guess everybody can relate with this. we have these group by all here, and what you see here is from select where, so it's not like this really specific SQL stuff where we say have, which is kind of, you always say select and then from, and it's more natural to say actually from this table I want to select, and you can happily do this here. And completely new, just released this night, therefore it's a new notebook, it's Instant SQL. I just create a table employees here, reading my JSON file again. And what it can do with, in the web UI, for example, is from employees, select, and I only want the column ID, and it just by typing it's actually executing the query because it's so fast underneath. You can just rapidly prototype your tables and your SQL. So really cool stuff. Now I said, hey, we're storing this in this memory database, and now we're coming to the points of it's in process, embedded. So we have this memory database. DuckDB itself, don't push too much on this DB part of DuckDB. It's not like I replace some Postgres database with it. It's more like a SQLite database coming to this data. So in this case, we're having, if you don't say anything, the database you're having is just in memory. It's kept in memory. If I create a table like this, the table employees, it's created in memory. In this case, it's even just a pointer to the JSON file. Sometimes it's cached within the memory. Sometimes it's read when the data is needed. And here you can actually see, hey, we're using the memory database now. But we can also create database files. For instance, by using attach persistent DB, the persistent DB file is now stored here, just in this. In the same directory I started the CLI in, create a new table in this, also re-JSON again. I can attach also to SQL database files, so to database files that are stored in S3, for example. Here it's stored in S3, and it's and I can show what is in there. So I attach to this one, DuckDB, Ducky catalog it's called. There's some views in it, and those are the views that are defined in here. And actually the views are defined as a select from an S3 bucket, not another view as a select from an S3 bucket, another view as a select from a Postgres database, so it can also be Postgres, and another one is an iceberg scan, so reading an iceberg table. What you can actually do now, which is kind of cool, and like, hey, you want this data, it's distributed everywhere, no problems, here's a database, and this database file which I downloaded is like a few kilobytes only because it's just metadata. In it are the views, and the views say the data is there, there, and there, and you can just query the data. So if I query the customers table now, I actually query everything that is stored in S3. So kind of a lightweight data catalog style if you want to share data. Pretty cool stuff. So now I have this file saying move over to, and there's missing PyCharm. And I just quickly start the presentation mode. This is the first thing. So of course DuckDB is like, it's written in C, it's basically fast, but hey, we want to use Python for it, don't we? So you can just pip install DuckDB. You get all the embeddable stuff as well, so all the DuckDB engine, then you can just use DuckDB SQL, write SQL code, the same SQL code as before, and print those stuff and show it. Or you can use the DuckDB Python API, which is not like completely raw string, but only 50% raw strings, where we say like, okay, we read the JSON, we select all columns, exclude payload, and we aggregate type and count as count by group by type, and we order it. Just let me quickly run it. No. So this is the result of, should be the first time, and this is the second time. So this took 2 seconds, and the fast one where I don't print the time should be way faster because the first start takes a little bit more time. So easy to use in Python, but it's getting even better. We also have a good Python integration. So we're having some data here, our customers and the salaries dict. We're creating a Polars data frame, we're creating a Pandas data frame in here, and we just query them. So we just write DuckDB SQL, and we query from the Polars data frame and join it with the Polars data frame. and it magically replaces this one here with knowing this. This is the Pandas data frame, and this one is the Polars data frame. And underneath, how is it connected? What does they use in between? Apache Arrow. That's the common discriminator in data by now, I guess, if it comes to exchanging data. So we can just select here, and then we can return the result that we have here as a data frame again, or as an arrow table again, or as a Polars data frame. So it's really easy convertible between all the memory types and all the data types we want to have, and it's all arrow in between. Therefore, it's really, really fast and not no conversion cost. So running this as well, just to prove that it runs. So here we're having, this is the first one where we do the computation, then a Pandas data frame, an arrow table, and a Polars data frame underneath here. Yeah, so easily to use, and therefore really easy to use as a drop in your existing workflows and notebooks and whatever you have. You might just use DuckDB in between. So, and last but not least, there's something called browser here, and browser says, hey, go to shell.duckdb.org. That's what I show you. DuckDB is not only written in C and available as Python library and whatever, a few other libraries, but it's also a WebAssembly module. So it's also compiled to WebAssembly. And this is actually running within my browser. There's no client process somewhere else. It's just running in my browser as a C packet or as a WASM with C code. And I can execute all the SQL queries. It's not all that, like, all extensions are supported, but it works pretty well and works pretty good for some data analytics. Where is it else? So a shell is nice. Where is it used, for example? If you go to Hugging Face and go into datasets and Hugging Face, you have a SQL UI next to it where you can explore this dataset. This is actually DuckDB WASM inside this. So it's actually using the data. It's actually in the browser where you quickly analyze what is the data in which I would get with this data set, how does it look like, and can explore it. So this was a real quick demo, but I think it gave a good explanation of, hey, what is it capable of, and what can we do with this. So analyze local, analyze remote, analyze from a blob storage. We have the SQL additions. We have the database files. We can do data sharing like with the catalog file. We have the integration in Python. We can run it in the browser, the Hugging Face dataset browser. We can actually read from Hugging Face, so it does support the Hugging Face protocol natively, if you read data from Hugging Face. So a few words more on the conception level now. I already said it's more like SQLite. And if you have a look at this, you can relate most likely. So SQLite is an embedded transactional database, the most widespread database in the world, because all of you are using it most likely right now in your pocket, because on all of your phones it's running SQLite. DuckDB is the same, but it's more focused on analytical use cases. And it's not too much, as I said, yeah, there's a database part with the database files, but for me it's mostly like a really, really fast embedded query engine. That's the most important part for me. Yeah, DuckDB files are good, but it's more like the query engine. It's portable, so it doesn't need any external dependencies. DuckDB itself is really like just pure C code without any other dependencies, not the extensions. We are coming later to this. We have a lot of clients, pip, Java, R, JavaScript, TypeScript. You can just install the CLI as I did with Brew. You have it with Rust, so in the end it's C underneath. You can run it everywhere. You can run it like on the PC, on the browser. You can run it in a Docker container. This is an example of Okta. They built a data processing pipeline with it, but just putting this into a Lambda function and starting Lambda functions and stopping Lambda function as they need it. So just using DuckDB in a Lambda function. Pretty simple to use case. Recommended video if you want to take a look. It's quite flexible because we can read a lot of data formats, especially read because coming later, Delta, Iceberg, write support, not there yet. But we can read a lot of data files. We can, from different locations, HTTP, S3, Azure, GCS, and so on. We can also read existing databases and connect those, and we can join data from different databases and data sources. We can go to Pandas, and we can export it as NumPy. We have, if you're using R, it's also compatible with deployer, so it's really flexible and fits in most of the, in a lot of ecosystems. And it comes with a lot of extensions. For instance, all the stuff that you have seen here, all the data formats on the left, the storage or the remote protocols on top and so on, it's all extensions. It's all not the core DuckDB. The core DuckDB, as I said, is without any further dependencies. If you load extensions with this, you get those further dependencies. And all of the features are actually extensions. You don't recognize it most of the time because they are auto-loaded. So for instance, HTTPS, JSON, Parquet data, they are auto-loaded. As soon as you do a read Parquet or read delta, the extension is auto-loaded. But there are some extensions that need to be loaded explicitly, like the spatial one where you can do spatial computations for this. So current state, DuckDB, we are in version 1.2. Version 1.3 will be released mid of May, most likely. It's the current idea to do so. 1.3 will focus a lot on all the lakehouse formats, so Iceberg, Delta, performance improvement there, and all the stuff. Yeah, and their overall claim was at the beginning, hey, let's build a correct system first, and then make it fast. And you're seeing like this, hey, we support Delta files, we support Iceberg. That's the first part, it's correct. Now we are proving the performance, and you see it like every release with DuckDB is like, you see someone on LinkedIn claiming some huge performance gains, and here as well, and here as well. They're really getting faster and faster all the time with the support, for instance, for predicate pushdown and all this stuff. So this is all nice tech, and we love it, but what to do with it now? That's the good question. The one thing is these local prototyping and exploration. I get some data thrown over the fence. I get somebody hands me a Parquet file or whatever, and this is on S3, and I only have the access keys, and this is really easy to get into the data and take a look into it, and all this stuff. This is the first one. No config, no DBA, just single tool everybody can run. We replaced our local unit tests, or our PySpark unit tests with DuckDB during execution. There's a library called SQL Frame, which mimics the PySpark API, which can have different runners underneath. DuckDB is the default runner. And we just run our unit test against DuckDB, in this case, way faster than spinning up a PySpark session, which takes, on an enterprise laptop with Windows and all the stuff, about a minute minimum. We can build analytical applications and APIs way better. So think a lot of you building products right now where it's not just create, read, update, but where it's more like, hey, we need to analyze the data. We want to do some self-serve analytics for the users. That is actually something we use DuckDB in projects already. So I'm more like a data engineer guy. My company is more like software engineers, but they actually using DuckDB as well. So hey, this is really cool. This lets us create fast, responsive UIs, and just DuckDB. Hey, it works also with TypeScript. Nice. So I got them on board, and they don't have to learn Python, which for some reason they don't want to. And reducing costs. So really replacing our PySpark jobs with DuckDB. Nico sits in front here. He has some examples about what did he tell me, from 2 hours to a few minutes. I have some as well. So really like, because if the data isn't that big, you can easily process this with DuckDB and spare a lot of money compared to using PySpark. You're doing this by having short-lived instances that really only run when the compute runs, and don't do it distributed, because distributed oftentimes is more than you need. And you can actually use it for data processing pipelines. I mean, you can write, for instance, with DBT, it's SQL, you can write all the pipelines as well. There's an asterisk on top because, as I said, write support with all the lakehouse formats is currently not supported. So if you want to write there, it's not that good. But yeah, so this is kind of, I think we will get there. Most likely I won't start with this one at the moment. So limitations, we have some Limited multi-user support. You have one user that can read and write, or you have multiple users that can read, but you don't have both on a database file, on a DuckDB database file. It's not for write-heavy workloads, it's really query engine made. The write support for Lakehouse formats I already mentioned. It's single-noded. Right? For me, it's a good thing because it makes things simple, but you can scale it up horizontally. You can just scale up by bigger machines, bigger machines, bigger machines. But I mean, this has 32 gigs of RAM, so and it's still you still need a runtime. It's just a library. You still need something where it's executed. A Docker container running in Kubernetes, a Lambda function, whatever. So it's really just a library, and there comes a lot of complexity that because DuckDB is so easy and simple, but yeah, because they don't care about where it's run. For instance, if you're running Spark, it comes with all the cluster, with all the execution environment as well. Limited on time. So what are the implications on data architecture? The one thing is, before that, we already had Pandas and PySpark as the option. So we either could have all the data which fits into memory, then we could use Pandas, or we had to use PySpark. There was nothing in between. And with DuckDB and also Polars, of course, we have this bigger than memory processing as option. We can process data that is bigger than memory because it only reads the portion it reads, it caches data, it offloads data. So this is the one thing that is really important if it comes to data platform. We're also using it for an alternative query engine. So we have an example where we're using Databricks, storing data in Databricks with the Unity catalog, but the data is small, to be honest. Databricks is a great platform for all the governance stuff and managing the data, but actually we want to use DuckDB to query the data because, hey, it's just a gigabyte or 2 or 5. And with the new token vending mechanism that is available in Databricks, we can actually do this and use DuckDB to read the data, an alternative query engine besides all the big proprietary distributed stuff. And the important part, the simple data-driven applications. We can build customer-facing analytics application where, in an extreme case, basically, one customer gets his own customer database and just uses this data. If it's small enough, you can just have those DuckDB file or a Parquet file or IceBag file, and this is queried by the customer as soon as he uses the web UI. And if it don't use the web UI, then the data is stored in S3 where it basically costs nothing. And you have the query engine embedded in your web application and just query the data when it's needed and don't have it running all the time, keeping costs low. And this is DuckDB visions. Maybe we're going behind those two-tier data architecture. What do they mean by two-tier data architecture? Usually we have like an application where the data is stored, and then we move all the data via ETL processes and whatever stuff over to some data lake or data warehouse where we do all the other processing. And DuckDB, in my opinion, is something that brings those two closer together. We have the applications where the data is created, managed, and we have the analytical part, and we can bring analytics actually to the application. No need to first show it to a data warehouse, then build some UIs on it and some Looker dashboards that are then integrated via an iframe into a web application. No, we can actually build it into the web application itself. And therefore, maybe we're coming to a shift left in data flows. Not having the data lake and data warehouse at the end of the flow, not having this at the afterthought when creating applications. Sometimes we think about data, but it's more like, hey, maybe data is the central part, and application is one point using the data, and BI and machine learning and AI and analytics is just another user of this data. So it's getting more data-centric in this case. And with that, come to the takeaways. Great for exploring data analysis, easy to use. You've seen it. It's a huge momentum right now. You could call it a hype, actually. In my opinion, it will impact and simplify data architectures in the long run. And we already use this especially for data-driven application. And this gap, I think, is going to close even more. Thank you.
All right. Thank you for the great overview. I also like the infographics. It's really nice. Also, nice showcase. Right, we do have some questions on the Slido. I'm just going to start and rapid fire this. If I already use Databricks and read Delta tables with Spark SQL, where does the application of DuckDB come in here?
Basically, less overhead, less costs, and most likely faster if it comes to certain cases, definitely. So, but in the end, it depends on how much and how big your data is. If the data is so big that it can't be handled by DuckDB, no worries. But if it's small enough, this makes things easier. But you don't get all the user management authorization stuff, and also if you need this, you have to stick to the platform tools.
Right. How well does DuckDB integrate with tools like dbt or Dagster?
So with dbt, it's pretty simple. You still have dbt. dbt needs a SQL engine. DuckDB is your SQL engine. Done. No, doesn't matter if it's Postgres or Snowflake or whatever. With Dagster, basically you can either use dbt in between, depends on what you do, or you can just use Dagster to run SQL queries somewhere, for instance, in DuckDB. To be fair, Dagster directly to DuckDB, not seen that often. It's more like for the ETL case, which I said, maybe not the first part because the write support is not that good.
All right, how do you decide between Polars and DuckDB?
Between Polars and DuckDB. For me, so first of all, do I want to write Python or SQL? Okay, taking this. The other one, for me, Polars is a data frame API written to process data and ETL data and transform data. DuckDB, for me, it's really like these embedded, really easy to use, more like database and SQL stuff. Yeah, you could, maybe you would not use Polars, for example, in a data-driven application. It's more, feels more like it's a tool from writing data to A to B, not to analyze data on the fly. But in the end, I'm pretty sure those converge at some points, and it's just a matter of preference.
All right, now rapid fire. Is DuckDB a threat to cloud data warehouses like Snowflake?
A threat? I'm not sure if it's a threat. Definitely not, because cloud data warehouses like Snowflake and also Databricks bring all this platform stuff and all these ecosystem with you. But I'm pretty sure that they will incorporate those easier, simpler processing modules. Otherwise, or have to enable people to actually use this, like Databricks already does. But it's not a threat. Although there's a company called MotherDuck, as with every open source project, there's a VC-backed company in the end. Which do this cloud data warehousing as well, based on DuckDB. Might be interesting how this turns out. Might be a nice competitor towards the proven and bigger companies that are there.
Right, last question. Does DuckDB have its own SQL dialect?
It actually is, so it's full support of the Postgres dialect plus X. That's basically it. So if you use Postgres and use the Postgres dialect, you can just continue with it. But it has some additions, like the group by all and all this stuff.
All right, thank you. With that, we have to close. We're on time. Give a round of applause to Matthias.
Thank you.